So our second metric that we provide to you, in addition to SLO results, is the growth model set of results. I'm going to explain this as a step-by-step process. This happens a little bit differently if I go into the weeds about the technical code and models that we run. This is meant to be kind of an abstraction to understand what are we trying to get across in a growth model process, and it goes step-by-step through that. The first one we do for a step is to think about, or we collect all the spring and fall test scores for students across New York that participate with us. We collect student data and determine demographic and other adjustments based on those data that we collect. And we collect the NWEA test results directly from NWEA. That allows us to know how much this year did English language learner status, for example, seem to impact the growth of students, or other factors that we calculate. And you see some numbers here. These are not the real adjustments. This is just a slide that represents the idea that some of these factors, like the starting point of a student or how long the test window was, might adjust up or down for how much students tended to grow this year in New York. But once we have those adjustments, each student gets a customized statistical prediction based on their characteristics. That can include all these factors that we have here on the screen. So some of those are student level factors about their academic history. Some are about characteristics that we receive from the SERS data about an individual student. Others are about the classroom average in which the student is learning alongside other students. We customize that prediction for each student. In this case, this student grew, or their predicted MAP scores to grow 14 points during the year based on the growth of similar students from across our reference group. Then after we collect the end of year scores here, we can figure out if each student exceeded or did not meet their prediction and by how much. On the left side, we have a student with a predicted score there visualized. In this case, a student's actual score was 5 scale score points or RIT points above what we had for their predicted score. On the right is a student whose score was not meeting the predicted score by 4 scale score points. So we do that for each student, and in essence, some students do better than typical based on similar students, and some students do worse than typical based on similar students. We average that all together to find out for a school students, did they tend to beat or not meet their predictions, and by how much. We can also do this at the teacher level, but here is a school just as an example. On the left, school A, you can see by those upward facing arrows that those students tended to beat their predictions. And when we average it all out, these students tended to beat their predictions by about 3 RIT points higher than what similar students across the state seem to achieve. And on school B, here's an average where students did not meet their predictions, in this case by a little under 1 RIT point. And if you want to turn this into value-added terms, which is something sometimes people want to talk about it that way, on the left side, school A has above average value added, and on the right side, school B has below average value added. So we're kind of determining, when we look at that group of students, did they tend to beat their predictions or not meet their predictions, and by how much. Then we translate that onto a 0 to 20 scale to let us know, is this a case where students tended to be about average in their outcomes? In this case, here's Mr. Harris's classroom. And in this case, some students ended up beating their predictions, some did not meet their predictions, but it kind of averaged out. That ends up being a 16 on the 0 to 20 scale, which puts Mr. Harris right in the middle of the effective range for the Heidi distribution. And here are some extremes. On the left, Ms. Johnson had their students that did not meet their predictions by a wide margin. We take that as evidence that these students did not grow as much as similar students across the state, and likely due to the contribution of the educator after we've made all these other adjustments. That would put Ms. Johnson in the ineffective range. And on the other end of the extreme, Ms. Lopez had their students by and large meet their predictions, and in some cases by a wide margin. that would result in a Heidi score above the effective range if we saw students that were really beating their predictions based on how similar students performed during this year. If you want to nerd out a little bit on the cut points, these are z-score translations. A z-score of 0 would mean on average, your students met their predictions exactly. So a number that's positive means your students were growing faster than similar students from across the state. And a negative number would mean those students are growing slower than similar students across the state. We have these cut points and we translate it to 0 to 20 based on how the advisory council co-developed it with us. Another box slide here about which students are included in the results. For the growth model, again, K through 10 are the grades and grades that we're covering here in the analysis. This time, in order to be included, a student must have both a fall and spring MAP growth test score, but it doesn't have to be with the SIRS day, the BEDS day. A student must also have demographic data in the SIRS data. Since we're trying to do an apples to apples similar student comparison, we want to know the demographic characteristics of students in order to include them in the analysis. So we must be able to find them in the SIRS data and have filled out information to know more about the student so we can make those comparisons. We also must have the student linked to the teacher in the SIRS data between the fall and spring MAP growth test events. That lets us know that that teacher taught that student during the period that we're evaluating based on the growth between those test scores. There's a minimum amount of instructional time. It's a teacher must be responsible for at least 2.5% of a student's instructional time in the content area. Usually we're seeing much larger percentages, and by and large, those are large portions, 50% or more, but sometimes students move around between teachers, or maybe there's more than one teacher contributing to a student's growth during that period. We had to set some minimum bar in order to have a student count in some fashion towards a teacher's outcome. And we do weight that. It's not like a 2.5% and then you get full credit. We weight it by the percentage of instructional time that is associated with a teacher or student. We have to have an instructional responsibility weight above 0. That means that sometimes we have teachers that are linked to a classroom, but they might have a 0 in that instructional responsibility weight. We take that to mean even though the teacher was linked to the classroom, you're designating in the SIRS data that that teacher had no instructional role within that classroom, and thus we would exclude that relationship from our results. So if you're missing some teachers, there's a chance it's because that instructional responsibility weight is set to 0. And then finally, there's the exclude from the evaluation indicator. If there are students that should be not counted for some reason, that would be the field that we would want you to have a 0 in. And I think I misspoke earlier when I was talking about editing the instructional responsibility weight to 0. That would be more about the teacher not having an instructional influence. I think the better thing to edit in case there's a student who needs to be excluded would be to edit that exclude from evaluation indicator, because that's at the student level. I was a little rusty on that. Here are the levels of results that we provide to you. This is in some sense similar to the SLO results. We have all subjects combined. We also have subject specific results, and we provide them for teachers, grade level teams, and school level. Since this growth model is about finding the impact of educators, we do not provide student level results in the growth model. We're looking for how do groups of students tend to grow, and we do that at the teacher, grade level, team, and school level. There is a chance, as with any year, that we might not have enough data to provide results for all of the grade levels that you'd like. For example, if there are just a few districts that are testing in kindergarten or grade 10, et cetera, we might not have enough of a reference group to do all of the grade levels and subjects that you would wish to have. We do not have that same limitation on the SLO side of things because we get the national growth norms to be used. But here in the growth model world, there may be some cases where we say we don't have enough data to produce results, but we'll let you know when we send those preliminary results over for which grades and subjects we have coverage.